Intriguing galaxies across the universe. Hubble's exceptional views of the cosmos have allowed astronomers to examine galaxies better than they ever could before, resolving features that would otherwise elude detection. Its observations continually reveal intriguing galaxies with surprising features, both near and far, showing how different they can be from one another, but also how they relate. Hubble, like all telescopes, is a time machine that astronomers can use to see into the past. Because light from the universe does not reach us instantly, but takes time to travel vast cosmic distances, Hubble reveals galaxies not as they are today, but as they appeared when their light left those galaxies millions or billions of years ago. The farther the galaxy Hubble studies, the farther back in time it sees. Faraway galaxies are earlier versions of those seen nearby. By observing galaxies at a range of distances, Hubble helps astronomers piece together the story of how galaxies have evolved over time. In addition, each galaxy has a story to tell about its own history and ongoing evolution. Some galaxies observed by Hubble divulge secrets about the role supermassive black holes play at the hearts of their galactic hosts. Others tell a tale of how stars there were born, lived, and died, and how intergalactic encounters can spark new episodes of stellar birth. Some exhibit different stages of collisions as they merge to form new, even larger galaxies. Still other galaxies show how they can assemble into gigantic clusters, creating the largest objects in the universe bound together by gravity. Excavating a prehistoric galaxy in our cosmic backyard. While using Hubble to study stars within one of our own galaxy's star clusters, astronomers stumbled across something they did not expect to find: a faint dwarf galaxy hidden behind the cluster's bright stars. Along its lengthiest dimension, the dwarf galaxy spans only 3,000 light-years, which is 30 times smaller than our Milky Way galaxy. It is also about 1,000 times fainter than the Milky Way. Nicknamed Bedini after the leader of the Discovery team, the galaxy resides a mere 30 million light-years away, which is not very far beyond our local group of galaxies. Bedini appears to be relatively isolated, at least 2 million light-years from the nearest large galaxy. Its stellar population suggests the dwarf galaxy is also very old, about 13 billion years of age, or nearly as old as the universe itself. It likely experienced a burst of star formation when it formed, but has remained quiet ever since. These qualities make Bedini a fascinating galactic fossil from the universe's early days. Witnessing a rash of star formation in long quiet dwarf galaxies. 4 billions of years to tiny dwarf galaxies lived quiet lives out on their own in a relatively empty part of space, far from other galaxies that were growing from mergers and igniting a rush of new star formation. But less than 100 million years ago, these tranquil galaxies joined in on the action and suddenly started turning out new stars at twice their previous rate. Called Pisces A and Pisces B, the galaxies were first detected by ground-based radio telescopes as small blobs of dense hydrogen gas. Hubble's observations confirmed that they were dwarf galaxies located roughly 19 million and 30 million light-years away that only recently began forming stars in earnest. Because hydrogen is the fuel needed to make stars, the high concentrations of hydrogen in Pisces A and B provided a clue that these galaxies hadn't yet used up their hydrogen in the star formation process as more developed galaxies have. Stars often form in earnest when their host galaxy encounters a cloud of gas outside the galaxy. The lack of prior active star formation in Pisces A and B suggests they lingered in the local void, a region with very few galaxies and very little gas to trigger new star birth. They are now entering a more gas-rich environment and appear to be located near the edge of a filament of dense gas, which is likely interacting with the galaxies to spark their late swell of star birth.